So in our previous example, we have seen that how to interface one potentiometer and how to read the value and how to display it through the serial monitor. If you have not checked that, see the video description below for that previous tutorial. Now in this tutorial, I'm going to display the same reading, which is already being displayed over the serial terminal. But now I'm going to display the same reading using one 16x2 LCD. So it's the same circuits which we have used in our previous tutorial. So that analog potentiometer is connected to the A0 channel, and that converted digital value is again that's displayed to the serial monitor. So to display the output, so we need one LCD. So we can include that from here. So you can search the component list and see the 16x2 LCD module is here. Okay. So this one. Okay. Now take a look on this LCD module. So there are different pins. There are so many different pins are present. So as you can see, the DB0 to DB7, those are the data pin. That means, so total 8 pins are used for data. Those LED anode and LED cathode, that is the backlight of the LCD. And in actual, this is the virtual one. In actual cases also, you will get the same thing. And this is the supply and ground. And then this V0 pin, basically see the contrast pin. That means it shades the contrast of that LCD pixels. Okay, so you can use one potentiometer to vary the contrast. That means to whether the dots will be more darker or lighter, you can change that. And those 3 pins are basically control pins. The RS stands for register select. That means that before sending any data, okay, so first we have to send some control signal to this register, and say again this register select perform different LCD operations. Means you can clear the content of LCD, you can shade that with the pixels from where. That means this is one 16x2 LCD. So we have 2 lines, and each line there is a total 16 characters. So you can set the position by selecting by setting the appropriate value in the register select. Okay. And this is the read write option. Okay, so basically in the LCD there is another one controller. So you have to interface that LCD controller with the Arduino. Okay, so it's a difficult job, but don't worry. So there are so many customized libraries that are present. So you have to just include that library, and everything can be done by using a single line. So let's complete the connection. So just check the ground and VCC. So let's we are creating a separate ground pin here. This, and then we have a VCC pin. Yeah. And similarly, just change the LED anode and LED cathode. Those pins will be connected to that ground and VCC, and it's better if you use one kilo ohm resistor without connecting it directly to the 5 volts. It's better to connect it through some 1 kilo ohm or 220 ohm resistor to limit the current. Now, talking about the other configurations, yeah, this V0 pin, that's basically contrast. So ideally it should be connected to a potentiometer to set the intensity. But remember, when the V0 is connected to ground, the intensity of that LCD pixel is the maximum. That means it will be the darker one. So here in this work, I'm going to connect it to the ground one without using any additional potentiometer. This is connected to ground. Similarly, LCD cathode, I'm going to connect it to ground, the same as before. and then remaining part RS, RW, and EN, and just and the DB0 to DB7. Yeah, LED anode. So we want that one register to be connected with that. So and this terminal should be connected to supply. This one. Now, rest of the part, see, we have 8 data pin and we have 3 control pin. Now, this LCD can be operated using 2 different modes. You can use total 8 pin at a time, or you can operate the LCD in 4-bit mode. That means you can use only 4 data pin. In most of the cases, people use only 4 data pin to shape the pin of the microcontroller. So whenever using one controller, the input-output pins of a microcontroller, so generally it is limited. Okay, so in this work, okay, so we can manage 8 pin, but see, when you are doing some other operation, so some other IO pins are engaged with that. Okay. So you cannot use or utilize total 8 pin to drive one LCD. Okay. That is not required. So we can, in this work, we can operate the LCD using a 4-bit mode. That means only 4 data pin. That is DB 4 to DB7. DB4 to DB7. This 4 data pin will be used to send the data. Okay. So let us see how to connect it. So before doing that, so you can do something with that code. Okay. So this code already exists because this one is the previous code by sending the data to a serial terminal. So what we are doing, so check here, there is option libraries. So we are working with the LCD, so we have to include the LCD library, liquid crystal. Let's check include library. Okay, liquid crystal.h. Then we have to connect that data pin to the controller. So the data pin connection to the controller, that we are using pin number 2, 3, 4, and 5 of the Arduino to connect the data pin. That means D7, just a minute. The D7, this one, is connected to pin number 2, this one, D6 connected to pin 3, similarly D5 connected to pin 4, and DB4 connected to pin 5. Now talking about control signal, so I'm going to connect that RS register select to pin 12 and EN enable to pin 11. RS, this one, I'm going to connect it to pin 12 and enable pin to pin 11. Okay. And the other part, that is read-write operation. For read-write operation, so in maximum cases, we are going to send the data to the LCD for display purpose. So basically we are doing the write operation, and this RW pin, it is should be connected to ground. So let's connect it to ground. This. Now our connection is done. So you can see that connection chart here. So which pin will be connected to the physical pin of Arduino. So you can refer to this image. Now it's time to code this. So we already have this existing code which is used to display that data, to print the data of a serial port. So we are going to modify this. So what we are doing, so we are first we are writing the code for that LCD part. Now see here we are defining the name of those pins which are connected. That is R is connected to pin 12, EN to 11, D4 to pin 5, D5 to pin 4, D6 to pin 3, and D7 to pin 2. Now remember those D7, D6, D5, and D4, those are the pins, data pin of the LCD. That means I'm talking about DB4 to DB7. And RS and EN is register, select, and enable pin. Then you have to initialize the LCD. Initialize the LCD means, so you have to send those data and you have to call that LCD function, which is inbuilt function, which is implemented inside this header file. So liquid crystal LCD, this one, okay, so that basically initialize the LCD module. So this header file will automatically do the necessary task for the initialization. It will send some data through this DB4 to D4 to D7 pin and using the register select. Then first we have to configure the LCD, that is rows and columns. Okay. So for that we are using this LCD.begin. That means basically it's a 16x2 LCD. And then if there is any garbage value which is already being displayed over LCD, so we can clear that by using this command. Then we can display one welcome message here. So when that board will be power on, so some welcome message will be displayed and it will remain on for 3 seconds. Welcome hackers. Okay. Now in the next case, that means inside the infinite loop, so what we're doing, so first we are initializing the column. Yeah, another one thing, when you are not using any column, that means we have 2 columns for LCD, column 0 and line 0 and line 1. So by default, it will select line 0. If you are not sending any commands, so it will set this. That means this welcome hackers, this message will be displayed in the first line. Then in the second line, I'm going to display the data, that is this LCD.set cursor, is 0, 1. That means now the cursor is at the second line. And then later I'm going to display that analog value. Okay, so let's put this line LCD.print. It will display this one, analog value equal to this line, and followed by we have to print, or we have to send that value which is the same, that means the analog value, this one. See, the analog value is already available. Okay. which is being displayed over serial terminal at the same time, and we are sending the same value to LCD. Okay, this one. Now we are giving some delay. So that's all about this code. Now let's run it. Yeah, let's see. The first line is being displayed, and now see the analog voltage equal to 5 volt. At the same time, you can check the serial monitor, and serial monitor, the analog value is printed, that is also 5. Okay. Now you can change the port position to analog voltage equal to 2, and at the same time, you can verify it from the serial monitor. See, it is 2. Okay. So our circuit is working. So just check. So after 3 seconds, the reading will be displayed, and see, if I set the port position to 0, it will be 0. And if I vary the port, it will convert the value and it will display it. So that's all about displaying a value, any sensor value, or any result or any message in a 16+2 LCD. And you can download this code, and you can compile this code, and you can dump it to the original Arduino hardware board, and you can design the same connection